How's it going, everyone? This is Gray with Puppet Mastr Labs, here to go over our new Ozone Engine module for the Unreal Engine 4. Today, we will be talking about ModSys DateTime. Now, I said it was a new module, but for those of you that might have already checked it out in the past, yeah, I'm a little late on getting this tutorial out, but you don't need me to tell you how crazy of a year it's been for all of us, so hopefully you guys will forgive me. So, before we get into it, if at any time you do need some more information on this module, be sure to check out the demo level we provided. It's something of our own little Unreal Museum level thing. And as this module is more about functionality over cosmetics, yeah, please forgive the lighting. At any rate, the examples here break down the primary aspects of this module into a decent amount of detail, so be sure to check that out. So what exactly is ModSys DateTime? Well, to put it simply, it's a framework that takes Unreal's existing DateTime system and adds a whole new layer of functionality, while at the same time kind of simplifying it in a way. You'll see what I mean by making it simpler in a little bit, but as far as the most notable functionality, ModSys DateTime allows you to determine a conceptual date and time, modify its operation and passage, and then allows any blueprint, widget, or any other object to utilize that date and time and react to it depending on the requirements of you and your game. It provides all of the pieces needed to implement fully configurable clocks and calendars with just a few clicks. And it's not just for the cosmetics of clocks and calendars. You can inject any aspect of your game into the date and time system to incorporate an entire date and time mechanic catered to your game. You can also trigger anything in the game based on the date, the time, or both. With dozens of additional features present and plenty more to come, ModSys DateTime can help transform your game into a completely synchronized experience for your players. By the way, if you enjoyed this video, like, subscribe, and hit that bell if you're interested in seeing more of what Puppet Mastr Labs is up to, and be sure to leave any questions or comments down below. I'll leave a link in the description that will take you to the page on Puppet Mastr's website where you can find additional information, media, and links regarding this module. So, for those of you that don't know what a DateTime data type is and haven't already connected the dots, a DateTime is a variable type in UE4 that represents a date and a time. It is worth mentioning that a DateTime variable type is a structure, so it can be split into its components. So you're going to have your break DateTime node, take DateTime node, but if you drop these down, these are the components that it has. It's 7 integers, and it's typically going to represent year, month, day, hour, minute, second, and millisecond. Now, this isn't UE4 exclusive by any means. DateTime is a common data type in many programming languages and environments. I have seen in some cases that some of them do go so far as to include like microsecond in their variation, but off the top of my head, I couldn't tell you which ones. Implementing ModSys DateTime into a UE4 project is pretty straightforward. Whether you are introducing it into an existing project or starting completely from scratch, you're going to go about it pretty much in the same way. First thing you're going to want to do if it's an existing project and you already have one is locate your game state. If you don't have one, you're going to create one. So I'm going to right click in the content browser, go to blueprint class, and then under here I'm just going to type in state, and I'm just going to use the game state base for this one. And we'll just call this game state. All right, and again, if you already have one, find it. If you don't, we're going to create another class And this is going to be our game mode. And again, I'm just going to use the game mode base. Call that game mode. Now, your game mode and game state are specialized classes that handle certain things that have to do with your game. I won't get into the details in this video. If anyone has any questions, feel free to, leave a comment. But as far as the scope of this, just, roll with it. So your game mode, if you double click on that and I bring it over to the correct monitor, is your typical Blueprint interface. A lot of this you're not really going to need to pay attention to. In fact, if I close this and open it back up, you'll see that it switches to the simpler Blueprint editor, and this is all we're going to need for this particular example. So under classes, you're going to see a whole array of different classes that you can pick from, or I guess, select. So we're looking at game state base here, and that is just the default game state class that a game mode uses. I'm actually going to switch this to, interesting. I'm going to go with this one. We'll see how well that goes. But basically this is just telling my game mode to pick or to use that game state class. Now let's go ahead and set this up to make sure it works properly. So if you go under your blueprints toolbar option here, you click the little arrow, you're going to see down here game mode. The current project game mode is game mode base. So I'm going to go over here to select game mode base class. And again, I'm going to guess the one that does not have a tooltip is mine, so this one is not mine. But I'm going to choose game mode. And that is telling my project that the default kind of fallback game mode to use is the one that we just created here. And you don't necessarily have to do this, but you can provide a world override. And again, it's just kind of habit for me. I'm just going to choose my game mode, and what that does, if you actually go into the world settings, and if you don't have this, go up to window, type, or select world settings, and that'll bring up this tab here. But if you look at it now, it's changed to game mode, and the selected game state is game state. This isn't a great visual example for these changes, but bear with me here. So now that we've got that set up, we're going to go into the game state. Add over. So the game state, like the game mode, is kind of your typical Blueprint editor interface. The one thing that we need to do special with this is if you go up here to add component, drop that down, type in manager, you're going to see something called a DateTime manager. This is a Blueprint actor component that comes with ModSys DateTime, and this is required for the whole system to work. You click on that, it'll add the actor component to your game state. Go ahead and compile and save that. And click on it, you're going to see a DateTime category, and this is going to have all kinds of options that basically determine how your date and time, or how your clock and calendar in your game works. And we'll get into this in another section. So for this section, I threw together a basic example to help illustrate what the manager can control and the type of information it can pass along to actors and other objects within UE4. I have a basic cube here with a rotating movement component, nothing special going on. Then I have a blueprint actor with a text render component inside of it. Now this actor is accessing the manager we've got in our game state up here. I won't go into what that looks like in this section, but we will be going over how to set all that up in the next section. So back in the game state, we're going to take a look at all of the options that the DateTime Manager component exposes to the game. With it selected, under the Details panel, under the DateTime category, first two we're going to look at are the initial game date and the initial game time. If I drop these down, you'll see that they kind of go hand in hand because they're pretty much the same 7 components that a date-time structure gives you, just split into 2 different structures, and the month being an enumeration of 12 months. Now, these variables set your game's date and time to whatever these are when you start the game. So whether it's generating a new level or starting a campaign, whatever the game's case might be, this is how you would determine what date and time the game starts at. If you look in the middle here, when we have access to our manager, we can get the initial time and date, we can get the current time and date, and we can get the delta time and date. And what these are all date time structures. The initial returns basically what this is as a date time structure. The current returns whatever the obviously current date and time it is in the game right now. And the delta basically subtracts the current and initial and gives you how long or how much time has passed since the game has been started. Now, the next option we're going to take a look at is the track gameplay duration boolean. When enabled, ModSys DateTime logs how long the player has been playing this current session as well as overall. If you want to keep track of how long a multiplayer match took or how long it took for a player to beat your campaign, then this is what you want. Now, on that note, all this does is track the duration. It does not create any kind of save information or config files or anything like that. So it is up to you to store this information and propagate it in whatever way you see fit that works for your particular setup. That being said, these are the 2 functions that you would use to retrieve that information in the form of a time span. So the best way to go about it would be to override your endPlay event here, grab your information with your manager, and then store it or do whatever you want with it. If you need to manually clear the current session time, maybe the character died and has to respawn from a checkpoint, this reset duration function is what you're after. It'll clear the current session duration. Something else to keep in mind is that you cannot set this boolean in-game. You can get the value for whatever reason you may have, but in order for tracking to work properly, this does have to be explicitly set via the manager at the start of the game. Now, to actually utilize my example here, we're going to take a look at the sync rate and the time dilation options next. As a reminder, if I go back into my level here and hit play, you're going to see January 1st, 2000, midnight, and a spinning cube. If you pay attention to the seconds here on the clock, you're going to see that it is counting up every single second. Hit stop and go back to the game state. We're going to take a look at the sync rate first. Currently this is set to 1. The sync rate is how often in seconds the manager is going to send a signal to all of the date time components that are currently reading from it to tell them what the current date and time is. So if I change this to 2, file and save, and go back and hit play, you're going to see now that my clock here is updating every 2 seconds instead of every second. Now keep in mind, this does not change what time it is or affect the time whatsoever. The sync rate is literally just allowing the date time component that this blueprint is using to only know about the changes in the date and time every 2 seconds. I go back to my game state now. If you set this to 0.5 in this case and compile and save and check that out, you're going to see basically the same functionality we had before. There's no visual representation that would suggest that this is updating, every half a second or twice a second, however you want to say it. So normally updating every second in most cases is enough. Now, as far as time dilation goes, this functionality is already present in Unreal Engine 4. We just kind of consolidated it into the DateTime manager. Time dilation is the speed in which time passes. So a setting of 1, which is the default, is no change. It's just real time. Anything lower than 1 is going to slow time down. Anything higher than 1 is going to speed time up. So if I go back to my example and hit play, you'll see the clock counting doing its thing, and then the cube doing its thing. If I go back and set my dilation to, let's say, 0.1, compile and save, cube is moving significantly slower, 1/10 of the speed in fact, and then the clock is eventually going to go up by 1. So it's now basically taking 10 seconds for the clock to count a second. Something to keep in mind is that time dilation does affect the sync rate, but the sync rate does not affect time dilation. If I change this to, we'll say 5, compile and save, hit play. Well, hopefully that's what you expected. Set that back to 1 for now. So this is our getter and setter for the sync rate. Nothing crazy about that. If you right click in a graph, type in dilate, you're going to see get actor, get global, set global, and then get and set custom. These are all the built-in UE4 options. If you drag off the manager, type in the same thing, you're going to be able to get the time dilation and set the time dilation. This is the variable that we were just messing with. And then you're also going to see a function here called dilate time. What this does is essentially go ahead and set the variable here to whatever you input and change the Unreal Engine's global time dilation to reflect it. It's kind of a shortcut to dilating the system that you're working with. So next we're going to look at the hour ranges. If you drop this down, you're going to see 4 more drop downs, each with a start and an end integer value. If you read start, it says hour a range starts with minimum of 0 inclusive, and end says hour a range ends with maximum of 24 exclusive. What this means is that you've got basically 4 ranges of the day, which are morning, afternoon, evening, and night. And this is how you would define basically what hours make up those ranges. This is kind of a cosmetic, based on your game kind of system. By default, it's basically 6 to 12 for the morning, which if you look at it, start is inclusive, end is exclusive. What this means is basically from 6 to 11:59 a.m. is going to be morning, but as soon as it rolls over into 12, it's going to switch to afternoon, which starts at 12. And then same for the rest of them. Now these are just 2 pure functions that take in whatever time it is and then returns the daytime and nighttime, and then morning, afternoon, evening, and night. This will basically say if it's morning, this will be true, and then technically the rest of these will be false. The simple one consolidates morning and afternoon as daytime and evening and night as nighttime, just in case you only really need kind of one or the other. Now, the last of the manager's options we're going to take a look at are the time weights. You drop this down, you're going to see 3 integers. You've got hour weight set to 60, minute weight set to 60, and second weight set to 1. not every game is going to use the same timing system that every other game uses. By default, 6061 is mimicking real time. There are 60 minutes in an hour, there are 60 seconds in a minute, and there's one real time second in a second. If you think about a game like Five Nights at Freddy's, I don't know the exact weighting that they use, but let's say in game an hour lasts roughly 5 real time minutes. If I wanted to mimic that in my game, what I would do is I would set the hour to equal 5 minutes. Now, if I go back, try this out, you're going to see that roughly every second it's actually going to count up 12 seconds. And with the proper formatting for a clock, this might just look like you've got, every few seconds you're going to see it tick up in minutes. This is a pretty basic but pretty powerful feature, as it doesn't actually mess with what time it is. You don't have to deal with any dilation. This is just how your time is actually weighted out in the game. Now, just like the track gameplay duration, you can only get this in game. Basically, the idea is when you set up your game, you have to kind of already know how you want it to weigh out. So there is no actual setting of it. You can only retrieve this information for whatever reason. So one more quick honorable mention before we move on to the next section. Anywhere you have access to the manager, two more functions that you also have access to are the pause and resume functions. And they basically do exactly what they say. Pause pauses the entire DateTime system, and resume resumes it. So if you want it so that when your player enters dialogue or opens their inventory or whatever the case may be, you can pause the entire system. Once they leave dialogue or close whatever interface it is, you can resume it again. So you already got a little sneak peek of this in the last section, but I want to take a look at all the different components that ModSys DateTime has to offer. If you look into the ModSys DateTime folder and then into the components folder, you're going to see 9 different assets. Now, we've already taken a look at the DateTime manager, which is the actor component that we put into our game state, but you have 4 other actor components as well as 4 widget blueprint components to choose from. And if you look at their names, you've got analog clock, digital calendar, digital clock, and then a base date time component for both the widget blueprints and the blueprint actor components. This is necessary because of the way that the blueprint architecture and the widget blueprint architecture differs in Unreal Engine 4. So we'll take a look at how to implement each of these here next. Back in the museum, if you take a look at number 10, you'll see an outline that shows how DateTime components are implemented into blueprint actors and widget blueprints. If we take a look at our BP analog clock demo, which is open here, you'll see the analog clock asset that we've provided, and then on the left you'll see a line here in the hierarchy. At the top is going to be your scene components, and then under that is going to be your actor components. And this one, as you can see, has an analog clock actor component already added to it. And we got that through this add component menu, much like in the game state from the earlier example. If you click on that, you can either search, but in this case we will scroll down to find the Ozone Engine category, and you will see the 5 actor components that we were taking a look at earlier. Now, the analog clock, digital calendar, and digital clock are children of the DateTime actor component base class. If you don't know anything about inheritance, what that means is that all 3 of these have the same functionality that this one provides, but with additional functionality based on what it is. So in this case, the analog clock has analog clock functionality on top of its parent class. Let's take a look at the widget equivalent of the analog clock demo we saw earlier. We look at the widget blueprint analog clock demo, which is already open. You'll see pretty much the same setup, give or take, as the blueprint, but you'll notice there's no subset of functionality over here like the actor components provided in blueprints. I mentioned earlier that widgets and blueprints differ, and the main difference is that inheritance is handled differently. Widgets don't really inherit the way blueprints do as far as being able to create a child of a blueprint and all of its scene components would, follow through to that child. Widgets, you have to basically add functionality and variables and things like that, and then inherit it a certain way. But you won't actually be able to pass along anything in the hierarchy. We go back to the content browser and go to our content folder and right click. Now you can create a widget blueprint just outright and give it one of our components. Let's do this a different way. If I go to blueprint class and down here, if I search for, let's just say analog, you're going to see that my analog clock demo we were just looking at is actually a child of the WBP DateTime analog clock, which is one of our components. If I click that and hit select, we'll just call this DT widget and open that up, we're going to see that the DateTime widget is actually the root of this particular widget. If I wanted to add something into this like an image, we'll see that we can actually drag it on here. That's because the DateTime widget component, again, if you look under the Ozone Engine category here, you'll see our 4 ModSys DateTime widget components. These are the demos that are in the demo folder. But these components are actually built with what's called a name slot here in the common panel. And what this does is allow your widget to accept a child. So right now, my widget here has all the functionality that the pure component has, and then I can add additional functionality in the graph as well as variables. If I click on the eye here and do show inherited variables, I'll see everything that that DateTime component has that is now accessible within the child widget we have just created. So let's say you've made a much more attractive analog clock blueprint. How do you actually go about it telling the time? If I go into the event graph here, that's it. On event begin play, you take your component and call the set hand components function, and then pass in whatever hands your clock has, and then the component will literally do the rest. Now, something to note here, it even says, note, any hand input pin can be excluded if it is not present in the blueprint. So if you've got a clock that doesn't have a second hand, just simply don't plug one in. But this is as simple as it gets. Everything is done, I guess externally, internally, depending on how you look at it, but that is the same with the digital clock and digital calendar as well. You've got a set display component where you pass in the text render that is going to display your time or your date. And that's really all it is. Same with the widget blueprints. Now, this is our analog clock again. If you look at it, all you're doing, because widgets are a little different, again, you're going to end up calling the parent construct as well, doing the set hand components, and notice you don't have to actually target anything because the widget blueprint itself is a DateTime analog clock component. Pass in the hands here, and then you call update clock. And that's, again, it. Same with the digital clock, same with the digital calendar. Can't really be any simpler than that. Much like the manager, the actor components and widget blueprint components expose additional options so you can further customize how your date and time is displayed. If I click on my analog clock component here and look on the right, I'm going to see a DateTime category under the details panel with several options as well as a subcategory. Any option that is not in the subcategory is going to be universal to all of the actor components and widget blueprint components. First one here is source. If I click on this, I'm going to have three options. Now, game means that it is inheriting the date and time from the manager. System is the local date and time on your particular machine. And then custom allows you to choose a custom date and a custom time for your blueprint or widget to display. If I go back to my level here, I've thrown 3 clocks on the museum wall. The first one, if I check out its instantiated component, is set to game. The second one is set to system, and the third one is set to custom. If I hit play, you're going to see, since we haven't changed our manager's initial date and time, it's just going to start out at 12. Right now it is 8:34 here, so my system time shows that. And then this one is actually a custom time that I set up through our details here. If I go to custom time, this is basically 3:47 and 25 seconds. So the date time passes boolean is basically controlling whether or not time is actually passing for this component. If you turn this off, you can emulate a broken clock, for instance. If I go back to my demo and hit play, I'm going to see that my custom clock here is just simply ticking. If I hit stop, go into its component and toggle this off and hit play, basically nothing's going to happen. Now, under that, turn this back on, we've got custom passage. Because this isn't waiting for the manager to tell it when it changes, because it's set to custom, you can choose your own passage of time. By default, it's going to tick every second, like you'd expect. But if I wanted to change this to, we'll do every minute, and hit play, you're going to see basically the second hand doesn't even move, and the minute hand ticks every single second. So now that we've seen what all these components have in common, let's take a look at what makes them different. If I click on the analog clock here, and then click on its component, I'm going to see a clock subcategory. If I drop this down, you're going to have 3 booleans. First one is smooth hours, second one is smooth minutes, and then lastly, smooth seconds. Now if you read these tooltips, you can see it says, adds partial rotation to the hour hand based on the minute. This is the only one by default that's checked. What this means is that as the second hand goes around and the minute hand goes around, the hour hand is just going to slowly rotate all the way around the clock based on what the second and minute hand show. This is kind of the nature of your typical analog clock because the hour hand doesn't just snap to each hour. And you can do the same with smooth minutes and smooth seconds. If I click smooth minutes and hit play, because of the resolution here, it's probably going to be hard to see, but you can start seeing the minute hand rotate every time the second hand ticks. Now, as you can see, you also have an option for smooth seconds. Keep in mind that if I turn this on and click play, it's not really going to change anything. Because by default, the manager is only allowing this component to update every second anyway. So if I wanted to, I'd have to go into the manager and tell it to basically sync more often, which is our sync rate variable. And then that way we can have it so that the second hand here rotates more smoothly around the clock. Now, if we look at our digital calendar component, you're going to see it's got its own subcategory called calendar. And inside that subcategory, we have a date format and a pad date. Now, the date format is a text input that allows you to determine how your date is displayed using shortcodes. We go back into our ModSys DateTime folder and then into the resources folder. You're going to see two string tables, which I have open here. If we look at the date shortcodes string table, we're going to see a decent amount of shortcodes that you can use to display different parts of your date. So the first one, day of month, displays the days, missing an apostrophe, fantastic, displays the day's number out of the month. So basically 1 through 31. Be sure to read all these descriptions. There's plenty of options here, whether or not it's a leap year, how many days are in the year, what the year is, etc. So if I click play now, we're going to see the 1st of January 2000. But I don't like how there is a leading 0 on 1st. So let's go check that out. If I go back into the component, my second option here is pad date. It's a Boolean. If I disable this and hit play again, it's going to take out any leading zeros that any of your shortcodes might use. So in the time component, or the digital clock component, we're going to have similar variables. We've got a time format and a pad time. The pad time does the same thing, just with the time components, or time shortcodes. And the time format uses a different subset of shortcodes seen in this string table. There's significantly fewer, but you get the idea. Hour 12 displays the 12-hour format. Hour 24 displays it in 24-hour format. You've got a couple of time period, and by a couple I obviously mean 4. Uppercase with periods, lowercase without periods, etc. That does it for the component options, I believe. Now, as I mentioned earlier, these are all universal to pretty much every component, but for instance, the digital clock blueprint actor component has these options. So does the digital clock widget blueprint component. And the digital calendars subcategory options are the same for the widget variation as well, and so on. For this last section, we're going to take a look at the DateTime function library and DateTime macro library. If I open the function library, these are all of the public functions that basically power ModSys DateTime. All of the components we've looked at so far have their own built-in functions and macros, but these can be called from anywhere at any point. And they're typical utilities such as appending a date and time into a DateTime. You can modify your time spans. You can get a random day out of a month. Convert hours to degrees based on your analog clock hands, minute to degrees, second to degrees. Let's see. If at any time you want to get any info about a date, you would plug in your date and it would tell you the number of days in that year, whether or not it's a leap year, number of days in that particular month, things like that. You can compare date times. So if you take one date time structure and another date time structure, you can see if they're the same, if one comes after or before. Same with dates and times and time spans. There are a couple of useful utilities over here, such as the DateTime Manager, which basically goes into your game state, finds your manager, and returns it, which can be useful for pretty much all of your components or blueprints or anything using the DateTime system, this is just a shortcut node to get access to your manager. The week of the year returns the week number that the specified date is on. So if you plug in a date, it'll tell you what week out of that particular year is. The day of the week is another pretty useful one that takes in, again, a date and tells you what day that particular date is on. You can see whether or not something is a weekend based on if it's Saturday or Sunday. You can return random times, random dates, a random year, just all kinds of different functions here that can give you some kind of extra information when messing around with ModSys DateTime. Alternatively, the macro library here has, well, 6 macros. You've got a set for widgets and a set for actors. Just like everything else, you've got blueprint actor components and blueprint widget components. Well, your macros are divided the same way. The actors obviously take in an actor component. The widgets take in a widget component. And you can essentially trigger things on a certain date, at a certain time, or on a date at a time. And all you do is you plug this in with a date or a time, or in this case, a date time. And this kind of functions like a do once node, where as soon as this date or time hits, it's going to trigger the execution with a reset as well, if you want it to. Quick closer look at that. Open up here. If I drag this over, actually find it here. This is our trigger example in the museum. And basically how this is set up is we're setting up our display component to show it. And then on our sync event dispatcher, every single time it syncs, it's going to check to see what the time is. And in this case, we've actually got it set up as a timer. If I go back here and click on the timer, look at the component, we've got it set so that it's 1 minute and 28 seconds, which is pretty much what time the sequencer gets to this. And if you look at the custom passage, we've actually got a -1 in the second value, which basically makes this a timer that counts backwards. Another little trick there. If I go back in here, basically as soon as the timer reaches 0, it's going to trigger what it does. And I'll let you watch that video to see what exactly it does. Alright, that's going to do it for this one. As always, thanks for watching, and I will see you all next time.